Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This is our fourth video implementing a linked list in a file, hopefully the last one. At the end of the last video we had just finished writing remove, though I realized once the video was over that I had once again forgotten to change num elms. Clearly we need some testing here. And this leaves two methods left, an insert all and an iterator. So the insert all is supposed to go to the nth element. Well, we have some code that does that right here. And then we're supposed to run through this traversable and insert all of the elements that are in it after the rover. I say after. Let's go make sure in the API. Insert all at a given index. So no, that should actually insert before the thing that's located there. That's good. I believe that actually makes the code a little bit easier. So all of these elements are going to go in front of Rover, and they're going to go in front of Rover in the order that they occur in. So let's pull the elms, an elem from elms, and what I want to do for each one of those is, well, since I'm so bad about forgetting this, let's go ahead and increment the elements. And let's pull some code from plus equals and then modify it. So I need to get a new node. And this is not the Sentinel's previous, but the Rover's previous. We can actually make this a little bit more efficient. Var Rover prev equals read prev of Rover. Once we've found it, you'll see why I want to keep that there. So we create our new node. We're going to write out to this node and make it point to Rover's prev before it and Rover after it. Then we need to take Rover's prev and set its next to be the new node. And then we need to take Rover's previous and set it to be the new node. And okay, we're done. Except for the fact that we don't update Rover's prev. Well, what happens here is that the next time through, Rover's prev should be equal to the new thing that we just included. After all, we just wrote in to be Rover's previous instead of bothering to read it back through. So if I had this line, I could have used a val and stuck it down in here, but this is a perfect example of a time when it's nice to actually use a var so that I don't have to jump and read something in a file that I know exactly what the value should be. Okay, so that's a version of insert all. The last thing that we need to write is an iterator. So we want to make this return a new iterator. This should give me errors because we're missing some methods. It needs the hasNext and the next methods. And I'll just give them dummy implementations, except that's harder for the next. I'll put some curly braces there. What does an iterator need to remember for this linked list? In our previous linked list, the iterator kept a Rover, and Rover would have been equal to the Sentinel's next. We can start with something very similar here. I can set Rover equal to read next of 0, so it is the Sentinel's next. We have next as long as Rover is not equal to 0. This is equivalent to the Rover got around to the Sentinel. When we wrote a memory bank based doubly linked list with the Sentinel, this would have been Rover not equal to our Sentinel. So what about next? Okay, so next is supposed to give us back the value that we're at with our rover. So that would be val ret equals read data on rover, and return that. But it also needs to move us forward by one element, so rover equals read next on rover. Okay, I believe that actually completes all of the methods that we were supposed to write here. Granted, I found so many little mistakes in writing this that it just seems inevitable that something is messed up, so we should probably test it. So let's go down to our tests. We actually have a test for our mutable doubly linked list. We're going to make a new class, test file linked list. I'm going to open the test for the mutable doubly linked list and copy all the contents. Let's go ahead and let's grab those import statements as well. Okay, this is not a mutable doubly linked list now. This is a file linked list, file linked list. Except now when we create this, we actually have to give it a name. Okay. Oh, and we have to give it a record size because we're writing something out. Well, since we're only writing ints for this is a linked list of ints, we give it a 4. In addition, our file linked list, we're supposed to pass the reader and the writer. Okay, so the reader is simply takes the input stream and returns in.readInt. The writer takes an output stream and takes an output stream, and the value, and writes out out.writeInt of that value. Okay, now that's happy, and notice that everything is going to compile. However, it's not going to be happy, because it turns out one of the potential advantages of doing these things file-based is when I load this back in, it should attach to that same file. So that means that for every test, I'm going to keep building up on the same file, and that's going to cause us some problems. Things are not going to behave the way that we want. So to get around that, I need to have, just like I had an app before to set things up to begin with, I need to do something afterwards. And what I'm going to do here is I am going to take and remove that list. We'll import and then call delete on it. So that will delete, so basically every test will be run, it will create this file, and then it will delete it when it is done. Shall we see what happens? Oh, one failure out of, whoa, that was not what I wanted to do. Okay, move that back over there. Okay, one failure and lots of crashes. So what happened here? This was assert true that the list is empty. That's disturbing. If we create a new file and it does not say it is empty, we'll assume, now one of the things about this is that the is empty probably uses our link there. Num elms, if we create a random access file, I wonder what the length actually is. Okay, so all of those came out to 0. Which is what we would have been hoping for. So if they're equal to 0, it does this, and it should set num elms equal to 0. The test in the code is checking for is empty. Now, one of the challenges here is that we don't necessarily know what is empty calls. The most obvious possibility is that it calls length and checks to see if length is 0. So let's go ahead and check to see what happens in there. Getting length of 1, getting length of 3, getting length of 0. But we don't know which one of those was this test. Testing empty has a getting length of 1. So what happened there? So this says that num elms is equal to 1, despite the fact that it should have been initialized to 0 there. We'll print that out. And just to make certain, print line num elms. Okay. So here's the testing empty. It prints out the 0, says file was empty, length equals 0, and then getting length of 1. And that begs the question of how did that happen? File was empty, file was empty, file was empty, file was empty. And it's never getting to that second test. Well, I'm going to stop this video here, and clearly we'll be making another video to come back and figure out the bugs that we have in this code.